Hello everyone, welcome to the electrical circuit simulation series. In today's session we'll study about Zener Diode as a voltage regulator. So a voltage regulator is a circuit which gives constant output voltage irrespective of the fluctuations in the input and the changes in the load resistor. So this is the circuit diagram we'll be using. Let us see the components. So the first component, as we can see, we have a variable DC source. So this is a DC power supply. Okay, and when we move this wiper, this voltage the maximum voltage is 15 volt, so it starts from 0 to 15. So as we move this wiper, the voltage changes from 0 to 15. Then we have a series resistor. This 100 ohms resistor is a series resistor. It limits the current flowing through the circuit, and it also actually saves the Zener diode. So if this the resistor is not there, then large current will flow through Zener and destroy the Zener diode. Then we have a load resistor. So load is the point where we want the constant output voltage. So we connect it across the Zener diode. Then we have the Zener diode. This is the symbol of the Zener diode, and it is connected in reverse bias mode. As we can see, N is up to N is connected to the power supply through the resistor, and P part is connected to the ground. Then we have the ground connection to complete the circuit. And we have the voltmeter, which measures the output voltage, which should be, of course, we want a constant output voltage, so we connect a voltmeter here. Now we have something called as a Zener voltage. Every Zener diode has that Zener voltage, which actually is the breakdown voltage. So this Zener diode in our case is for fixed 5.6 volt. Okay, so one of the property of Zener diode is that it is having a sharp breakdown voltage. So in this case, we assume that we want output voltage to be fixed at 5.6. So when we change the when we change this voltage from 0 to 15, so as long as this Zener diode is working in reverse bias mode, we get a constant output irrespective of whatever input voltage we are giving. Let us see this. Now this is let us see the working. Okay, so what we do is we move this wiper from here to here, so we get this is 10.99 volts. So when this is 10.99 volt, the Zener goes in a reverse breakdown region, and okay, so this is a 10.99 volt, and here as we can see the output voltage is 5.4. so this voltage, according to Kirchhoff's law, will divide. So this is 10 points, so let us assume it is 11. So out of 11, 5 we get it here, and the remaining will come at the series resistor. So this Zener diode will hold this voltage of 5.5 up to this 5.4 to 5.5. Now in case, suppose if we increase this voltage, so previously it was 10.991, now we still increase this voltage, so from we get is 14.61. now even with 14.61, the output voltage would now be 5.6. So as we can see, there is not much significant change in the output. So if this is 14.6, we get 5.6 here, and remaining voltage will come across the series resistor. So even if we keep it as 20, suppose if we had a 20 volt power supply, if this had been 20 volt, then we would get 5.6 here, and remaining voltage would come across this particular series resistor. So what this Zener diode is having a sharp breakdown voltage, this voltage won't go beyond 5.6, and because this load resistor is connected across, both are parallel, so whatever voltage we are getting across this Zener diode, we get across this load resistor. So the voltage at the load remains constant irrespective of whatever voltage we are getting here. So that's all for this this explanation part. Now let's go for the simulation part. So now we are in the SimulIDE simulator software. So first we select the voltage source. So we have various sources. We'll select this one, this voltage source. Now for voltage regulator, we require an unregulated power supply. We don't have any unregulated power supply in this, so we have fixed, but we can actually change the voltage. So we'll do that. Then we require resistor. So we'll take a resistor here, from here, one resistor here, place it the series resistor. We require one more resistor. So there is a shunt, the parallel resistor, the load resistor. We'll place it here. Then we require the Zener diode. So we have the Zener diode here. This is the Zener diode. It will place the Zener in the reverse bias, so counter clock. Okay. Then we require a ground. So here we have the ground. This is the ground. Now we connect the components. So first we connect this, then we connect this, then we connect this one, and finally the load resistor. Now we need a voltmeter to measure the output voltage. So we connect the, just put it here, so this red terminal, place it here, sorry, and this one black, I'll put it here. Now this voltage source is of 5 volt. We need to change this. Okay, so I'll just right click here and go in properties. In properties, as you can see, max voltage is 5, so this won't work for us. We need actually a 15 volt power supply. Just put it 15. So now the maximum voltage is 15. So when we move this particular wiper from here to here, it goes from 0 to 15. So we are done. Now let us start the simulation. So I'll just start the simulation. I'll just turn it on. Now this much voltage, we require a voltage because this particular Zener diode, I'll just let you check it. So this particular Zener diode, if we study the property, so electric property, advanced property, as we can see, the breakdown is 5.6. Okay, we can even change this value, but I will keep it same. So breakdown is 5.6. So this voltage should be 5.6 plus something 4. Otherwise this Zener won't go into the breakdown mode, running in the breakdown. We want this Zener to work in breakdown region. So for Zener to work in breakdown region, we require Zener the breakdown voltage plus some more 3 voltages plus. So let us start with this. Just start the simulation. Okay, and then this voltage, let us start from 10 volt. Okay, so as we can see, the input voltage, this is the input voltage 10.32 and output is 5.16. so out of 10, 5 is coming and 5 is coming across this 100 ohm resistor. Okay, now if we increase the voltage further, okay, 12 volts, still there is 5.6. okay, the excess voltage comes across this 100 ohms. If you want to check, we can place one more voltmeter here. It will give the reading of this, of the voltage drop across this series resistor. So according to Kirchhoff's law, this plus this should be this equal to this. Now let us start this. So 5 here and 6 here, as you can see roughly. So if we increase it further, this is 9 and this is 5. So if we observe, this voltage is just around running, it is just adjusting around 5.4, 5.6, but all the excess voltage is coming here. So if we decrease it further, as we can see, this is 5.2. now this will remain almost constant, and the excess voltage here, you can see it was 5, now it has become 8, but this is almost constant. So this is how the Zener diode can be used as a voltage regulates the voltage across this. So we get a constant voltage across this. Now where this can be used, let us see the application also. It was not shown in the PowerPoint, but I will show you that what application we can have. Just remove this component, I don't need this. Okay, so what we do now is we just cut this, remove this. Okay, and we place LED here, so that we understand what the exact working of this. So here we have the LED, light emitting diode. I'll just place light emitting diode here. Okay, so this is the light emitting diode. Okay, now I want to connect and disconnect this particular Zener diode so that we can easily understand the working. So I'll just remove this and place a switch here. Sorry, so I'll just remove this and I'll place a switch here. So this is the switch. I'll just turn it around. So this is the switch. I'll just place this switch here. Now this switch, either it will connect this or disconnect it. Sorry, 1 minute. Okay, so there was no place of it is. So just connect this particular switch in series with this, so that I can actually connect and disconnect. So I just disconnected this now. So now no Zener diode is connected, so this circuit does not contain the Zener diode. Now let us turn it on. So now when we turn it on, if we increase the voltage, now this LED glows. This is yellow, it is glowing. Now if we further increase the voltage, so at a particular, now this red mark in this particular simulation shows that this LED has been damaged. Okay, now this LED has been, because it also receives more voltage and more current flows through this, and it destroys this a particular LED. Okay, now this power supply which we are using, if it is an unregulated power supply, it can supply any voltage, so it can damage the other circuits, thus it has damaged the LED. Now let us see what happens with the connection of this Zener diode. So I'll just connect this Zener diode with this switch close. This Zener diode now gets connected and we get a regulated power output. So let us now turn it on. So now when you turn it on, as you can see, even if we go to 15 volt, there is no damage to this because this voltage is fixed now. So this is how Zener diode can be used to protect many circuits where we require a particular constant supply. It can also be used to supply constant voltages. So that's all for this particular session. Thanks for watching.